Hello, everybody, and welcome back to another episode of Earth Growing Together. I'm Roger Hanson, your host, here with the panel, which consists of Bob Dub and my brother Robert Hanson. Welcome, guys.
Hey, Roger. Good to be with you.
Now, Mark Edworthy said that he is going to be a little bit late, but he will join as soon as possible. Um, and just ahead of time, I'm going to let everybody know that I'm going to keep it short when it comes to the weather today because we have had a lot of conversation off of the show concerning photosynthesis, which has been kind of interesting. And I know Robert is going to want to talk about that. So today I'm going to keep the weather conversation down to a low as much as I can so that we can get to that. But I am going to mention some stuff. So with that, I'm going to start that up and then we'll go around and see how everything's going in your neck of the woods, Bob Dub, and maybe Mark if he gets in. But with the weather this week in my area, I guess the best place to start is by taking a look at my weather here in West Frankfort. Okay, we've been dealing with some pretty serious summer heat. The temperatures are around the upper 80s and into the 90s. But we're also seeing temperatures begin to moderate somewhat as we move through the middle of August. Now, that doesn't apply to this weekend because Robert was telling me earlier that the temperatures are going to feel like they're up in the hundreds. So we've got a lot of hot, humid weather. Even on days whenever it feels, or the temperature says 90 degrees, it feels like it's got to be at least 98 degrees. So now with rainfall, let's talk about the rainfall. And this is one of those things where conditions can be completely different from one neighborhood to another. So the thing of it is when it comes to that, well, I guess the best thing to do is I want to with rainfall. I can just talk to you, Bob. When it comes to rainfall, did you guys get enough rain this week by any chance, or?
It's been raining solidly for 3 days. We haven't seen the sky. It's absolutely sodden. When you go outside, the ground squelches under you as if it's wet. There's water just lying on the surface. So wet. So wet.
You kind of took care of my next two questions.
Oh. Sorry.
That was excellent. I'm trying to keep it short, and you did a perfect job of helping me because I was going to ask you, did you have to water or anything, and how the soil looked?
We haven't even been able to go outside. The cats are beside themselves with fury because every time they put their noses outside, they're just soaking wet. They're coming in with wet hair, wet fur all the time.
Has it been affecting your lawn?
The interesting thing about New Zealand is that everything here is green all the time because there is so much water all the time. So yeah, it's been affecting our lawn in as much as you can't walk over it very well without the grass sort of squishing down into the soil. It's so wet.
Well, like yesterday, we found when it was doing the thunder, Roger went outside and he said that when I witnessed outside with a bright thunder without the sound, but it lit up. It had that pink color to it. And Roger went out there and he said that you could tell a big difference of the brightness and the lack of wind.
The weird part about it was it's like it was actually getting real dark, like in the middle of the daytime when it should be sun out. It was getting really dark. Robert looked out of the window and he said that he seen a bright light with pink in it. And just before that, I was outside and it was storming, or you could hear the storms and the wind like it was going to rain. And after he said that, I went back outside sat down on the back porch and everything was calm. The wind was gone. The sun, or it wasn't, sunny or nothing, but it was brighter than what it was. It went from almost a complete darkness to where it was somewhat visible.
Didn't you have a solar eclipse?
That was
yesterday?
Yeah, that was in England.
No, that's all over the world, bro.
Well, I mean, England's the one that was talking big about it. It's like they actually had a thing on the internet saying it's a dark day for England, and everybody clicked on it to see what it was about.
Well, I read something that said that the amount of energy that the moon blocked from the sun during the solar eclipse is more than all the electricity produced in all the Earth's power stations all at once in that small hour. There's more energy from the sun blocked than the Earth produced.
I know there was a bunch of weird stuff that had taken place too, because it was I was supposed to go on Nancy's show yesterday, and Mark Watashik was trying to get the show started, and when he tried to do it, it literally just shut everything down on there. So I don't know for sure if that was because of something that was happening in the sky or not, you know what I mean? But it just, and it's been weird stuff like that's been happening all
Did
through.
you see the sunlight bend when the eclipse happened?
No, I didn't see that.
Yeah,
Sunlight
you
bend.
look around on the edge, the sunlight from it would bend because of it. Heat, I forget.
Okay, so before we get caught up in all of that, let me get through this garden changes for the week, okay? Because this is where things are getting interesting for Southern Illinois. I'll get through that, and then we can get to the main topic and stuff, okay?
Yeah.
Okay, so we're now at the point where the garden is transitioning from peak summer production towards the beginning of the fall garden cycle. Now, Illinois Illinois Extension, it identifies Southern Illinois as having a larger growing season than Central and Northern Illinois, which allows gardeners to start earlier and harvest later, basically. Because we have gardening zones, and where Southern Illinois is where we're at, we're right at the tip of one gardening zone to another. So that makes it a little bit different for us than what it is in the north. Now, mid-August is absolutely not the end of gardening season, basically, is what I'm saying for this area. Now, with that being said, here's something that might surprise you guys and some people who are listening. We're in August, but that doesn't mean the gardening is winding down. Now, in Southern Illinois, we're actually beginning to think about the next garden, which is the fall garden. So you're going to see a lot of people who are transitioning from one gardening season to another, which is a lot of what most people around here do. They do the spring, then they'll do summer gardens, and then they'll do fall gardens. Now, I usually tell everybody at this point, look, you need to pay attention to your frost when your winter frost comes in, and I make it a point to do that because of where we live at right now. Most people like to do the fall gardening, and you really need to know when your winter frost is coming, because if you don't time it perfect, you'll end up losing your crop. So for anybody listening who's in this area, I just want to put a reminder out there. Make sure you know when winter frost is ready to set. So things that gardeners may be seeing right now, they might be seeing tomatoes producing heavily. You'll see peppers continuing to develop. Cucumbers and squash are producing. Now beans are starting to come up, and okra is also starting to produce too. When it comes to the vine crops, they're taking over their growing space, and some early season plants are beginning to decline right now. This is where I used to see the end of the cantaloupe season whenever I got into the cantaloupes. And so this would be about the time of the year where the cantaloupes would be fading away. Now, this is also the time when gardeners begin to clear space for the fall crops, which is what I was talking about before. So with that, I'm going to open it up and see if you guys want to talk anything about what I just mentioned or what.
Well, I
Well,
just had a. Oh, sorry, you carry on, Robert.
I was just going to ask, well, from one to the other, wouldn't like this, what do you call it? The solar rays would be slightly different because of the tilt of the world would be. I can't quite put it in that how each season of it and sunlight would be different type of re-enter or the plant. How would the plant the solar how does the solar oh boy I'll have
Well, don't worry. Well, you see, the thing of it is, Robert, just have a conversation. See, you're trying to intellectualize when it comes to this stuff. Just talk. You know what I mean?
Well,
We're not here trying to be scientific.
well, I was referring to like when how each when the earth moves a certain way each season and the sunlight goes from one to the other, how the weather is. And I was wondering, how is it that the plants handle how does the plants handle it from the sun?
Well, for me personally, when it comes to like seasons, I've noticed like none of that is really important. Like if you turn around and you try to grow like a crop that is supposed to be grown in our fall season in the middle of spring, it's just not going to grow. You know, now if you have it in a controlled environment, you can control what kind of weather it gets in like a greenhouse environment, for example. That would be different. But like if you're outside in the open air, it's just not going to happen. Plants seem to have a mind of their own. You know what I mean? So you have to learn to cater to what time of the year a plant wants to grow and when it doesn't want to grow, and then decide, okay, this is what I want to grow in the springtime because it'll grow. This is what I want to grow in the summertime because this is what will grow. And the same thing with fall. You know what I mean?
Also,
So because not everything grows just automatically any time of the year.
okay, so like the sun rays for the plants.
I don't even get caught up into all that. That's a little bit too technical for me. I know that this is what grows this time of year. This is what grows that kind of year. I don't know, Bob, Deb, but do you have anything to say about that?
Well, the vague thing that I have that's interesting is that kiwi fruit vines grow best in the summer if they've had a frost in the winter. If they have a frost while they're growing, it kills all their buds and all their flowers and their leaves and everything. But when the frost comes during the winter, when the vines are all empty and they don't have leaves on them, then when they grow again after the frost, they grow much more fruit. So that's a little bit different because you're talking about planting different things and I'm talking about something that's permanently in the ground. But it's just interesting how different plants respond in different ways to frosts.
Yeah, about your plant. Is there other plants that have male to female flowers? And does the male flower produce fruit as well the female of your plant?
There are definitely male flowers in the kiwi fruits. They grow one row of female vines and then one row of male vines. I think they both grow fruit. I'm not sure, but the males not as much fruit. Not significant amounts of fruit compared to the females, which are
How can
where
you
it
tell
will
apart?
happen. I can't. Okay, I would have to ask Callum how you tell them apart. I guess for somebody like me, you just go to the shop and buy the ones that say male or the ones that say female.
That's the way I do it too.
Yeah.
I mean, that's what I'm saying. It's like, um, you basically, if you're really into it, yeah, you'll be able to do it. But like most people don't even know
Yeah.
which one's a female or which one's a male,
No.
stuff like that.
Once they're in the ground, they're there, and so the only people that are interested in that are the guys who are actually growing them and selling them.
Right.
Yeah.
Because that is important for like producers, you know what I mean? But like when it comes to gardening, I don't know. I mean, if anybody actually has any comments on that, who does watch this now or even afterwards, feel free to leave some comments and give us some feedback on that, because I honestly couldn't tell you, just to be honest. I don't even know. So now we get to the fun facts. We get to the soil science. This is the part Robert likes. Because remember how I used to tell you whenever we were gardening together, I would be out doing all this other stuff, and there Robert was sorting through the dirt, getting all the rocks and stuff out. That's all he ever obsessed over. So we're gonna start talking about soil science, okay, Robert?
Okay.
Now I did find some notes that Bob Dub pulled up before. I'm going to keep that handy because we've got to keep them ready for you, because we know you're going to get into some hard-hitting questions and we're going to try our best to answer them. So the first thing I want to discuss is soil nutrition and plant health, and that would begin with calcium and how it's a part of building the plant. Now, calcium, for anybody who doesn't know, is an essential plant nutrient. Plants use calcium in the development and stability of cell walls and cell membranes. It's especially important in active growing tissues, which include new roots, new leaves, shoots, flowers. It's also important in developing fruit. You have calcium, which is also it has an important role in pollen tube growth, which occurs after pollination, basically. Now, unlike some nutrients, calcium doesn't move readily from older plant tissues to newer growth. So that means consistent calcium availability to active growing tissues matter, you know what I mean? So I guess my best question to you, Robert, is this: when we talk about calcium, we're not just talking about making bones strong. Why does growing plants need calcium? Do you know?
Well, I guess, like you said, the construction of the plant, the construction of the fruits and vegetables, and doesn't it like the pollen from other, they take it as well, whereas for materials for what it needs as well, the same material from one, they can use it for themselves too. And plus, it breaks it down to where the bees or anything else, but it does process of feeding the plant too. Like the secondary pollen come into the crops as well, and the heart root of the plant, it absorbs it and helps maintains the plant of the materials that it comes in contact with.
Okay. Now, before you go on any further, Bob Deb, do you want to mention anything when it comes to that?
The interesting thing about calcium is that it's a structural mineral. And so plants use it to build walls, their cell walls, their membrane walls. And you can't replace it very easily with any other mineral. Like there are things that you can replace in plants, like nitrogen or potassium. But with calcium, it's there. The plant is either strong or it's not strong, just like people. If people lose calcium out of their bodies, their bones get weak. Another interesting thing about calcium in people is that liquid calcium is used as a covering, a coating for the nerves, our nerves. So people who lose calcium out of their bodies become very, very agitated and they have nervous problems, they get angry very easily. And so there's a similar thing that happens with plants, not that they get angry, but they respond differently to the environment. So there's strange links between the role of calcium in humans and in plants. It's very similar.
Very good.
I have one question. Okay. Calcium, is it different from like poison ice, poison sumac, and evergreen?
Okay, so we're going to skip that because you're obsessed with poison ivy and poison oak, Robert. You drive me nuts.
About the pollen from it.
I'm sick of hearing about poison ivy and poison oak. we got to move on, man.
But calcium is calcium.
Yeah.
You can't change what calcium is. It's the same thing in everything.
Everything, even poison ivy and poison oak, same
Yes.
exact stuff.
Calcium is calcium, yes. The poison comes from something different.
You keep talking, I'm just picking on you. It's just okay. I swear, if I have to hear about poison ivy and poison oak again, I'm just gonna go ballistic. You know, I think it's the time of year because, like, this time of year around here, that's all you see is vines. You know what I mean? It happens usually right around the end of spring, and then like right when summer's coming to an end and fall's getting ready to happen. You see vines just growing everywhere. So I can see that being the reason why Robert's talking about poison ivy and poison oak.
I don't know specifically about poison ivy and poison oak, but I do know, like what I was telling you about the calcium being a liquid covering for nerves. I know that in plants, calcium ions help the plant to respond to things like drought or heat or cold or insects or disease, because they're the ones that send signals. Calcium sends signals. So it's an interesting thing to think about what sort of signals it would send in a poison plant. I don't know, but it's perhaps we could do some research on that and find out where the poison comes from. Is it calcium? I don't even know. But I do know that calcium doesn't move very well, like in your bones. Your bones, the calcium it stays in your bones, and with the plants, stays in the right place. It just sends signals.
See, that would actually, with what you said right there, that would actually fit into what we went over when we were talking about poison ivy and poison oak too. when it comes to like as a protection against like the environment around it. And then what was it? What tree was it the other day? We said that it, fungus won't grow around it.
Oh,
Was
yes.
that the great oak?
I think.
Great oak.
It,
Interesting.
later on, I can find out.
But what I was
Yeah.
referring to was that material in pollen.
In pollen.
Yeah. That because all the materials and construction would go into that pollen as well, wouldn't it? And plants adapt to the pollen because it breaks it down.
I think we already,
Pollen. Yeah. Carry
I
on.
think we already covered that. I was reading it just a little while ago. Calcium also has an important role in pollen tube growth, like the tube for the pollen.
Yes. Yes.
So
To
for
make
the,
it strong. Yes.
mhm. that you know now
It's like the cement of nature. Yeah.
now with that we've got to get into magnesium,
Mm.
which is this gets us into the photosynthesis connection. So we go from calcium into magnesium, which is another essential part plant nutrient. Now, one of its most important jobs is being at the center of the chlorophyll molecule. Now, chlorophyll is what allows plants to capture the light energy for photosynthesis, okay? Magnesium, therefore, has a direct connection to the plant's ability to turn sunlight into a usable chemical energy. All right. So, magnesium deficiency can cause older leaves to develop yellowish or yellowing between the veins, while the veins remain greener. Now, healthy magnesium nutrient supports healthy photosynthesis and overall plant vigor. So that is what we're talking about next. We are talking about magnesium. So my question here is, when you're looking at a green leaf, no, or better yet, when we're looking at a green leaf, I should say, instead of you, we're really looking at part of the plant's solar power system, basically. What happens then when the system isn't getting the nutrients it needs? That's my question. So,
Well, chlorophyll is the main thing for photosynthesis, and the most central atom at the middle of the chlorophyll is a magnesium. So if there isn't a magnesium available, then everything breaks down, and the plant can't convert the sun rays into energy at all. And that's why the leaf goes yellow and falls off. One of the reasons why. Calcium is very stable in the plant and it stays where it is, but magnesium moves around throughout the plant. So if it's limited, if there isn't enough magnesium, then the magnesium will move out of the old leaves, and it will go to the new leaves to try and establish new growth.
go ahead, Robert. Go ahead.
Okay, but letting it work too with the heart of the plant, with the fluid from the plant itself, how it all together absorbs all of that the material in, and the root has a thing about, our root has a thing about releasing so much of it, let so much of it out at a specific amount of time, and where at night, the plant has a better way of working it because of the temperature, and if plant, especially if plant is in distress at the time because of the heat and a lack of it, the plant can release some of it from the heart of the plant.
Sorry.
Well, it's confusing for me when you talk about the heart of the plant because the plant doesn't have a heart.
No, I mean down at the root of, there is a big heart, big one, in the center of the plant. That's the heart of the plant. All the material goes down into it, and it can go all the way down to 3 foot. The root system and the heart of it goes down. Because I took them up and I was asking, and they said that that's the heart of the plant.
Now, are you just calling it the heart of the plant, or is it like an actual technical term that you're using?
Actually, it is it is the heart of the plant. That's what they call it, because that regulates everything about the plant. The sun.
I can fact check you. So I can fact check you now. So you better have your facts straight, because
with each of it take all the materials.
I'm his brother Bob Dup. I can get away with talking to him like that.
I looked it up. It says, if you're using the heart as a metaphor for the plant, there isn't one single organ equivalent to an animal heart. But there is something called the meristem, M-E-R-I, meristem, which is the plant's growing heart. It's at the tips of the roots and shoots where you have actively dividing cells. They produce new tissues and essentially direct the plant's continued growth. That's very interesting.
I'm glad
So
I'm
it's
glad you're.
decentralized.
I'm glad you're keeping up on them, because you gotta be tough with Robert.
Well, because that's what I was referring to. I just didn't know about all that specific.
Well,
But they did say that there's a specific area that does all that.
right.
And
Now the Mary root, remember that. That's a very important term. And spell that.
someone's gonna have to remind me of that.
Well, spell that to me again, and I'll make a note of it. Bob
Okay.
Dub.
It's meristem, M-E-R-I-S-T-E-M.
Okay, got it. Okay, so I'm gonna keep that. That way we can keep the terminology going.
Yes.
Whew. I tell you, he's a rough one. I thought he was gonna get worse though, because like earlier we did notes and stuff, and like I remember you had to like pull up notes about ultraviolet rays and stuff like that. So I thought he was gonna go all hardcore on us and stuff. So he was being nice to us today.
Well, it's interesting because everything in the plant happens at the cellular level, and magnesium is right at the center of the cell. So, like thinking of the heart idea is kind of interesting. It's not real, but it's an interesting way to think about the cell working similar to a body.
Yeah, because what better way? Because look at the other types of cells, and like where you like with grass and weeds, I don't know what it is, but when you roll in it, how it has that thing about wanting to make you itch, like acid makes you itch on the plant.
That's when there's two things that do that, Robert. One is that the edge of the grass can cut your skin with tiny, tiny little cuts, and that can make you really, really uncomfortable.
Yeah.
But the other thing is that a person can be allergic to grass. Actually allergic, like you're allergic to, I don't know, what are people allergic to? Other stuff. Oranges or
I don't think Robert's allergic to anything. Okay, like
well, if
that
he
man,
rolls in the grass and gets itchy, then he's allergic to grass.
he's allergic to bicycles. Like you don't let Robert on a bicycle.
That's a different type of allergy.
Yeah.
I will put them down. I do.
He has had more accidents on bicycles than I have ever seen any human being have an accident on a bicycle. Like, it's amazing. So he's allergic to bicycles.
Allergic to bicycles and grass.
And
okay.
farm animal.
Well, no.
Oh, really?
He's
I'm
I
allergic
got hit by a
to
bull.
I have to tell you.
he got
Oh,
he got into he decided when we were living on the dairy farm that he was going to take, they give you these whips to keep the bulls and everything out of the way, from the gates and stuff, and kind of navigate them. He decided he was going to use it on this freaking cow's nose because she had to watch the gate while they took the manure out with the tractors because they were doing the manure, scraping it up off the pit floor. And his job was to guard the gate. And while he was up there, he was trying to be tough, and he smacked this freaking cow in the nose. And apparently, she was in heat.
No, it wasn't a she, it was a he.
Well, from what I heard, is she was in heat, and she ducked away. And the bull that was trying to get to her, seen that, and got mad and charged him. Hit him, he flew over the back of this bull, man, and just laid flat in manure.
I went up to like a third-story building.
And,
A guy in a tractor saw me.
yeah.
He
Sure.
said, yeah.
So-
Like one of those Spanish bullfighter people.
Well, a Spanish bullfighter that really didn't get he got the raw deal.
Yeah.
There was no fighting the bull in that situation.
I hate chickens more than anything. And the only reason that I can think is that when I was a tiny little girl, about 4 years old, my grandfather had about 5,000 chickens in these great big, like runs. They were called runs, great, huge, big cages where the chickens all scratched around in the dirt and whatever. And one day he sent me in to get an egg or some eggs. And there was a rooster there that must have come right up to sort of like my stomach. It was, I was a tiny little girl. And it jumped right up at me with its stupid scratchy feet. Man, I hate chickens. I hate chickens.
Okay, so now with that being done, let's go
Sorry.
to... No, you did great. Let's go to soil pH. This is
Okay.
what Robert loves to talk about. Now, soil pH, the pH level for soil is like the gatekeeper. Okay. Now, this is probably the most important concept when it comes to this section. Okay. Because soil pH describes how acidic and alkaline the soil is. pH doesn't simply like determine whether a nutrient is present. It determines how strongly it influences and how available the nutrient is to the plant. You know what I mean? Did that make
osmosis?
Right. So the soil can contain a nutrient while the plant still struggles to access it if the soil chemistry makes that nutrient less available. So like different plants have different preferred pH ranges. And that's why knowing your soil's pH can be much more useful than like simply adding fertilizer. So nutrient. The simplest way to explain it is like soil can have the food in the pantry, but pH pH determines whether that plant can get the pantry door open. You know
Because
what I mean?
inside the roots have lots of little holes in them, right?
Mm-hmm.
And for the nutrients to get out of the soil into the plant, it has to go through the little holes. But there's it has to flow like water flows. It has to go from higher to lower level. The nutrients in the soil have to go from the one side of the root into the other side of the root, and it sort of gets sucked through. So if the pH is wrong, then that suck doesn't work, right? And in fact, what can happen is the nutrients can go from the plant and get sucked out through the little holes into the soil if it's the wrong pH.
Right. And see, I was really glad when we had Callum on because he did a really, really good job of explaining a lot of that. When he showed the plant, and he said that the size difference was determined because of it.
Mm. Yes.
That right there was interesting when he mentioned that. So and I never even related the two together. You know what I mean? When it comes to
and remember, anybody can just go down to the local drugstore, chemist, or mainly supermarkets in the UK and Europe, and just buy some pH paper themselves. They can test their own soil.
Yes.
Now, see, Robert actually had an issue in that because, like, he wanted to do a pH test on everything.
Right.
You know what I mean?
Because it's fun. It's so fun.
Well, I mean, at first he did that, and he's starting to figure out like he doesn't have to do a pH balance on everything. You know what I mean? But like that was one of the first things he used to do. It was everything.
Yes.
Question for you:
Yes.
do you live in a heavy or light water area?
What do you consider a light water area?
Well, you know, heavy water. I just tap.
Well, I'll tell you. I'll put it to you this way:
with a higher alkaline
where we live, we have on one side of us the Mississippi River, and then on the other side we have the Ohio River, and they meet at the foot of our state.
And right outside of town, we got Big Muddy, a little creek.
Yeah, we've literally got a river named Big Muddy.
Yeah. Okay, so it's going to be like high acid.
Yeah.
Then.
I believe so.
Okay.
I believe so. Robert's what was the pH levels on the soil that you was always testing for? Was it pretty high?
It depended on if it was contaminants, like materials that was in it, like working materials, nails, and all that. That was real low compared to clean.
So you had less pH?
Yeah, when it came to contaminated soil.
Oh, yeah, okay. Contaminated lead pipes.
Yeah.
Issue, yeah, okay. No, thanks. How about you, Bob? Is your water heavy or light?
Hard or soft?
Hard or soft? Hard or
Yeah.
soft, yeah.
Hard or soft. So where you have hard water, you have high concentrations of calcium and magnesium ions in it because it's got a lot of limestone or other calcium-rich rocks. And the answer is yes. Here on the orchard, we have hard water, and it makes those white deposits in your kettle when the calcium comes out of the water when you heat it, and you get the white deposits.
Does it affect your plants that much?
Oh, you know it would have to.
Well, yeah, but how much? Is it dramatic or is it just...
We are not in an area where it's dramatic, but yes, it can be dramatic.
Okay,
It can be. It can stunt growth, and you have to put fertilizer in the soil to change the balance here.
No, in where I am in Devon, in the UK, it's very soft. It's fairly soft.
Which actually, this is actually the time when we start talking about the lime and changing the soil, because that's the next step. Because like agricultural lime is commonly used when soil is too acidic. All right,
That's right.
And many agricultural lime products contain calcium carbonate. Now,
talk about soil.
no, hold on. Let me finish here. I want to explain what lime can do. Okay, because this is important. Now, lime can actually raise soil pH, but at the same time, it can also supply calcium. It can also change the availability of certain nutrients as well. So lime shouldn't automatically be added just because a plant needs calcium. Okay, if soil pH is already appropriate, adding lime could actually push the pH too high. So it's ideally for gardeners, especially, they should test their soil first.
And those who I know a lot of Americans don't have kettles, but yeah, kettles is a good test. If you've got salt and rust build up in the kettle, or in another application. A couple of applications out there, but if you notice too much rust and salt building up in the kettle, as an example.
Yes.
And irons, steam irons.
Yes. Yes. Absolutely. The little holes get blocked up. Yeah.
Right.
Well, it is interesting because, again, it's about balance. It's about having that flow so you can have a soil that has calcium in it, but a plant in that soil that's not getting enough calcium.
Yeah,
and the reason will be that it's not getting sucked in,
right.
Because the balance is wrong.
Now, I do want to make a distinction here because before I mentioned it, Robert, how you are always talking about antacids, and this is a perfect time to bring this up, okay? Because remember our earlier conversation about antacids? Now, some antacids, they do contain calcium carbonate. Which is chemically related to materials used in agricultural lime, all right? But that doesn't make antacids substitutes for garden lime, okay? So agricultural lime is specifically formulated and sold for soil amendment. Okay, so don't think that you can go out and get antacids and put them in your soil.
No.
I don't know. Products like that are fairly generic, so then I'll put baseline. Let's say you're going tomatoes, you want more acid.
Mark, you're not going to put Alka-Seltzer in your yard, are you, dude? Seriously.
No, I'm lying. I would. That's fine. But yeah,
think about it.
There's actually a old wine tale in Britain.
Well, I mean,
yeah. So yeah, white vinegar.
Yeah, that's a good one actually, but not Alka-Seltzer. No, not Alka-Seltzer.
But yeah.
Well, what I was asking is that how when the soil's nice and dark, what's the material within it to make that soil rich, moist, soft to touch, and it crumbles compared to less dark and hard.
Okay, we talk about photosynthesis, and we also talk about water intake of the soil.
Right, nutrient uptake actually.
Yeah. Oh well, yeah.
Well, 2 parts to your soil. There's 2 parts to your soil, Robert. You've got the bits of rock, okay? If you've got a soil that's got a lot of just rock in it, it's usually a very light colored because it's got a lot of silicon. Silicon is very sandy. The sand is made out of silicon.
Oh, okay.
If you want that dark color, you have to add compost because that's the second part of soil. That's what actually turns sand into soil, is the decayed plant material. And decayed plant material, as you know, if you've just dug into your compost heap, is very, very black. Very, very black.
Right.
Okay.
Now, I want to add into this.
Are you big tree? Sorry. Are you big? Do you live around trees?
Oh yeah.
Foliage. Bushes, trees. So you've got plenty of foliage. You've got the ground we fertilize in itself. Every autumn or never.
Exactly, and that's actually something that I'd like to bring up too at another time. Whenever it comes to fall, especially whenever you're trying to protect your plants. Like if you want to protect your plants and you can't take them in for the winter, you can actually use the foliage to protect them if you want to keep them
A
outside.
blanket. Yes.
Right.
Yes.
You know.
Indeed,
But
yeah.
hold up,
Yeah.
I want to add into that, Robert, before you get going, because there's some talking points to bring into when it comes. These guys have hit something on the nose, which is actually important. Now, for a plant to use nutrients, okay, several things have to work together. You have to have has to be the soil, the water, the roots. You have the nutrients, and then the plant tissues. Now, nutrient availability, it can be affected by your soil pH, your soil moisture. You have to look at your root health. Also, the temperature. That's another one that's very important. And then, like how you're talking about the black soil, it's the soil structure and the organic matter, which these guys are talking to you about. Now, there's also something called microbial activity. All right, and that's a hard word to pronounce. But it's,
Bacteria. Yeah, bacteria. Really.
Right. Now that's
Bacteria.
very important. Like your bacteria and your nutrients concentrations; those are also very, very important. And there's an important gardening lesson here. All right, more fertilizer doesn't necessarily mean more growth. Like a plant can have plenty of nutrients available, but still struggle if its roots aren't functioning properly or the soil conditions prevent uptake. Okay, so keep that in mind when it comes to fertilizer. You know what I mean?
Yes. Fertilizer is a different thing from compost.
Right.
Fertilizer is a
Think of it like-
chemical. Yes, sorry, Mark.
Okay, so I was just thinking along the lines of baking bread or baking cakes. Cakes with more air in them. Bread, like I don't know, croissants with more air, or sponges like I don't know, Victoria sponge cake with more air in it. It's much more able to maneuver that air and make the cake much more fluffier and much more healthier.
See, now things are
Right.
kicking in. You're starting to put two and two together. See what I mean? That's exactly it.
You need that balance. You have to have, and the water has to be able to dissolve the chemicals, because the chemicals get into the plant. The chemicals don't move into the plant. The water moves into the plant. We should talk about osmosis on the next show,
Oh, that'd be
Roger.
cool.
Yeah,
That would be
that's
cool.
a good idea.
because it's the water that moves, and depending on how much is dissolved in the water depends how much can get into the plant.
But also, it's also about having the soil that is airy enough to move the water
Aerated.
through the soil.
Absolutely.
Yeah.
Absolutely. That's why a clay soil is so bad to grow plants in, because the spaces between the little clay particles are so small that they can be smaller than a water molecule. So the water molecule can't fit in between the soil particles.
But what I was asking is that when it
Mm.
into on the water, the salt is in with water, ain't it?
Yes.
You know how they say that the small things of salt in with the water?
Well,
And
I can actually answer that, and this is actually a real good. I like to call it the classic calcium mystery. Okay.
Mhm.
Now, this is like actually a great practical example for the audience and for you, Robert. Like, you'll often see blossom end roots on like tomatoes. You'll see them on peppers, squash, and other fruiting vegetables, right? Now, it appears as a dark sunken area of the blossom end of developing fruit, which is called blossom end root or rot. Okay. Now, the interesting part about all this is like the blossom end root or rot is associated with insufficient calcium that reaching the fruit. But simply adding calcium fertilizer isn't necessarily the solution. Now, the problem can involve water movement, and it can also involve calcium transport. All right, so it's basically the water movement that's taking place, and it's the freaking calcium and how it's being transported through the seeds. Now, this usually comes because of drought, irregular watering. There could be root damage that's involved. You also have like excessive soil moisture. Now you have to be careful about that, because if you have too much soil moisture, it can actually cause you problems. And then there's rapid plant growth. Okay, so, and then you guys were talking about salts. Okay, high salt levels in soil. That's another big deal. Now these can interfere with the calcium reaching the fruit too. Now, Robert, for me, the best thing I can say, and this would be a great line for you, okay, for me to tell you, sometimes the plant doesn't have a calcium shortage in soil. The problem is getting the calcium where it needs to go. That is an excellent gardening lesson, because it you know what I mean, it demonstrates why diagnosing the problem is more important than like simply throwing fertilizer at it. You know what I mean?
Yeah. So
sometimes too, and just one more thing, sometimes too, and I had a big problem, and I mentioned this before, I used to always try to save plants, and sometimes it's just not going to work. They're just not strong enough, and you got to let them go.
like peppers, for hot peppers, if you grow your plants within in a garden that has that type of built up salt in it, or however,
Yes.
would that make that plant even better, or that plant would
Depends
grow
on the
better
pepper.
than the regular other plants?
That would depend on the pepper species, subspecies. Obviously, peppers came from the U.S. Caribbean originally, so they are up to a point. What's the word? Environmentally. Well, much more maybe in hotter regions like California, Mexico, Texas, maybe not as far as north as you, depending on the species. But it's like anything, to get a tomato, depending on the species, to get it fairly ripe, you're going to have to feed a lot of water and be in a lot of acid, fairly acidy area.
Right. And it's like a lot of, and I think a lot of people, when it comes to gardening or just growing, they get this misconception like this is all natural. You just put a seed in the ground and let it grow. And it's not. I mean, you literally, well, you have to also do research, find out what
of course, whatever you're doing, do research first.
You know what
obviously.
I mean?
Yeah.
It's like I was just telling Robert too, like if you can't grow something in the fall that natural, well, you can plant it, I guess, in the fall, but it's not going to grow until freaking spring if it grows in the springtime.
Yes.
You know what I mean?
There was the seasons are there for a purpose.
Right.
Yeah.
So
Guys, here's something interesting. We're talking about the roots and we're talking about nutrients and things. But you know that plants are made out of carbon, right? All the actual leaves and roots and stem and everything of the plant are made out of carbon. And the carbon doesn't come out of the soil. It comes out of the air.
Mm-hmm.
And so the plant is built out of air.
I did not know that.
Breaks up the carbon dioxide. It uses the carbon from the carbon dioxide and it releases the oxygen. And that's where the actual mass of the plant comes from. And that's why you need sunlight. And so even though the roots and the soil are real interesting and fun and particularly important for somebody who's growing fruit, like tomatoes or kiwi fruit or vegetables like beans, that's where you get your nutrients. But the actual roots and stem and leaves are made out of air.
Yeah, but there is a small percentage of carbon from, let's say, leaves or animals or actual in the soil itself. But it's a small percentage compared to air.
Now, the beautiful part about this is I find both of them interesting because it's like when we spend most of our time looking at the part of the plant above the ground, we don't really look at what's going on under the ground as well. You know what I mean? Because under the soil, there's an enormous system responsible for things like absorbing water. It absorbs nutrients. It anchors the plant, and then there's that interaction with like the freaking microorganisms. You know what I mean? It also stores resources, and then it, stuff like that. So, like, and then photosynthesis. When you were talking right there, that made me think photosynthesis big time. You know what I mean? So you have two things going on. You got healthy roots that need the right combination of water, oxygen, nutrients, and like suitable soil conditions. But too much water can also be problematic as too little. You know what I mean? So water fills like the spaces between soil particles, and when these spaces stay saturated, roots can have like a difficulty getting the oxygen they need, and that brings you into the photosynthesis. You know what I mean? So before I get into it, what I want to ask you guys is this: like we spend all the time looking at leaves and fruits, okay? But how often do we forget about what's happening underneath the soil? I mean, do you guys really pay much attention to that when it comes to growing and stuff?
Sorry, say that again.
We always look at what's going on above the ground, okay? Like when it comes to looking at leaves and fruit. But how often do we forget about what's happening underneath the soil? You know what I mean?
Yeah.
Underneath the soil.
Right.
We should do a
bedrock.
series on insects and worms, or an episode on how worms and insects affect the soil.
Yeah,
And,
I think that.
Absolutely. The soil is made out of worm poo. That's what soil is. It's worm
That's
poo.
the great stuff right
Delicious. Just like the sea is made out of whale wee.
I wouldn't say
Isn't that
delicious.
yummy?
hence why it's so salty.
I'm being sarcastic.
I know you are. That's why I said that. I was like, don't say it.
That's what we eat. We eat worm poo.
Yummy. Delicious.
Yeah, but see, Bob,
Delicious.
Your
you
vitamins,
brought
all your
up the thing last
vitamins,
time about
yeah.
plants, about the seaweed and how there's oxygen. Okay, with all the sea life of the plants in the sea, if it does the same process as if it does on Earth, in here,
See, now you're getting excited. We're going to have to.
where
Interesting. We've come to the end of our time, though, haven't we? We can't really start a new one.
Yeah.
It's just 10 past now.
Yeah, it's coming to the end of the thing. Now, photosynthesis. The thing is, I'm gonna go through this last part. It's a small part. It's about photosynthesis. Now, this is the plant's solar engine, basically. This is what Bob Dub was talking about. All right. Now, this is where magnesium, leaves, water, and sunlight all come together. Plants use light, carbon dioxide, and water to produce the chemical energy they need for growth, while releasing oxygen as a byproduct. Now, photosynthesis ultimately provides the energy in the carbon framework that supports leaves, roots, flowers, fruit, and seeds. And that's why healthy leaves matter so much. A simple analogy to this would be that the roots are the supply department, the leaves are the solar panels, and the rest of the plant is the construction project.
but what about the pollen?
That's a good conversational explanation without getting too deep into biochemistry, Robert. So we're gonna stop this because we are at an hour, okay? And we're gonna come back and we're gonna talk about fertilizers. Does that sound like a good plan to you guys?
Yeah, definitely. considering what we've been talking about most of
No.
the night.
Robert, you
I
can't.
was just gonna ask one little thing.
Don't you never
Well,
ask that.
Okay, one more question.
Crop, in the crop area, crop circle, the soil, it shows.
Okay, we are not talking about crop circles.
No, I'm not
No,
talking about
you just said
Yeah,
You're
We're
done.
going from
I'm saying how the color of
Hanson
the
into
soil is different.
UFOology.
Okay, Robert, this is about gardening.
Yeah, I'm saying
Okay, hold up.
One program.
Later
Join us
on,
on Nancy show or something.
let me go ahead and end this because Robert is going crazy. He started talking about crop circles, and we will come back when we get him straightened out and back on track. Hope you guys enjoyed. If you have, please like, subscribe, share, make comments, say hello to everybody that is on here. You know, Bob Dub, Mark Edworthy, and Robert. With that being said, I'm going to go ahead and end the show before Robert says anything else crazy. So we'll talk to you later.